When you hear the phrase embryonic stem cells, what is the first thing that comes to mind? Do you find yourself thinking of genetically altering cells to produce the perfect human? Or do you find yourself thinking about your beliefs and what you deem to be unacceptable in terms of using these cells for research? What if instead of destroying and storing these embryos that eventually never get used, some embryos get donated to research? What if I told you that a single stem cell has the ability to create treatments and therapies for diseases that currently do not have one, such as Parkinson's or Alzheimer's? Should stem cell collection be allowed then? Does hearing the potential ability of these cells persuade you to think twice about your stance? Regardless of your decision, I am going to explain why stem cell collection is important through the research I have conducted about this topic. Now let's start with some context. What are stem cells? According to the National Institute of Health, stem cells are cells that are regenerative and can multiply themselves. There are two different types of stem cells, embryonic and adult. Now, what makes embryonic stem cells so unique is that they have not yet developed the genes necessary to turn these cells into tissue-specific cells, meaning they haven't yet changed from stem cell to heart-specific cells or from stem cell to blood and nerve cells. Since embryonic stem cells are basically the building blocks of life, they have the potential to become any type of cell they want to become. Adult stem cells, on the other hand, are fully developed. They have already developed into the cell type that they are going to be, and there is no changing them. Meaning, if you want to extract heart stem cells and use them to treat nerve stem cells, you can't. This is what makes embryonic stem cell collection so exciting. According to an article on DBC STEM, embryonic stem cells have the potential to treat heart attacks through repairing and replacing damaged tissue. Stem cells can help diabetes through repairing and replacing cells that don't produce insulin anymore. Spinal cord injuries now have a chance at treatment through stem cells by allowing them to repair and replace the damaged tissue. So if these cells have this potential to become any type of cell that we need them to be, why is there so much opposition to using them for research? And referring back to the DBSTEM article, one of the main oppositions of using embryonic stem cells is the belief that an embryo has life. This is a valid concern, but I want to challenge this perspective because I believe that the potential of these cells outweigh those concerns. In an NBC article that was written in 2019, Dr. Arthur Kaplan, who is a bioethicist and professor at NYU, states that there are over 90,000 abandoned embryos in the US. 90,000. And this was in 2019. Imagine the number today in 2025. In an article titled Abandoned Embryo Cryopreserves, there is a growing problem with couples producing a surplus of embryos and then abandoning those embryos once there is successful implantation. Think of all the embryos that could be donated to research. As I previously mentioned, a single embryo has the ability to differentiate or to multiply and differentiate into tissue-specific cells. Through this one embryo, researchers can discover just how cells differentiate, how they can induce an environment to produce tissue-specific cells, and how diseases come to be through studying the cells and the mechanisms involved. Imagine how much we can learn if it became standardized that abandoned embryos become donated after a certain amount of time rather than being electively donated by couples. Now, I don't want to attack the belief that embryos have life, but if there is life in an embryo, why not give this life that has been deemed abandoned a chance to help further research and help someone that has no current treatment for their disease. Something similar to this can be seen through organ donation. Organ donation provides new life to someone who is in need depending on the severity of their disease. If you have kidney disease and need a new kidney, there's a potential match out there for you to continue living. Why can't there be that same potential through embryonic stem cell collection? Now, as I come to the end of my speech, I want to acknowledge some limitations to making the possibilities to treat diseases from embryonic stem cell collection. According to the textbook, Stem Cells and the Future of Regenerative Medicine, as of right now, the reality of making these therapies for diseases is far from FDA approval. Scientists have mostly been researching with mice stem cells and seeing the properties of how these cells work. While genetically mice cells are close in relation to human cells, it still doesn't provide the exact blueprint for how our cells work. Not only that, but the cost of research has been limited by our federal government. While these limitations are crucial, I hope me explaining how the collection of embryonic stem cell collection is just as equally crucial for research to progress. Now let's go back to that first question I asked. When you hear the term embryonic stem cells, what is the first thing that comes to mind now? I hope in my speech I persuaded you to take a pause at what you think and really outweigh the pros and cons to the collection of embryonic stem cells. Embryonic stem cells are the future of medicine. They are the building blocks of life. In using them in research, we will be able to study just how stem cells regenerate. We will be able to understand the mechanisms of how these diseases come to be. All we need is to utilize the resources we have in IVF clinics through abandoned embryos, while coinciding with an ethical committee to ensure that the research being done is appropriate. One avenue of medicine succeeding is relying on the potential of embryonic stem cell collection.